So I've finished to set my environment variables. Does anyone have a question about the .env file? Yes, so my screen is not visible. So this private key, the way you get your private key, so when I was setting my private variables, of course, I didn't want you to see. So you go to your MetaMask and oh, I have the ATN. So you go to account details, show private key, then you put in your password and then you see your private key. So within those dots that are in the quotes, that's where you paste your private key. Then Infura RPC, you log into Infura if you are here in the last session, or you can go online and click how to get an Infura URL. Etherscan API, you go to Etherscan, sign in. After signing in, then you will get an API key. Is that clear? So those things, you paste them between the quotes where the three dots are. Then store them in that .env file. The reason we store them in the .env file is because they are delicate. In case you upload them on Google Play, on online or on GitHub, somebody can drain your wallet. So we choose to put them in .env file because the .env file is not uploaded. Hope that is okay. So now I want to deploy the whitelist. Is my screen visible, or my screen was not totally visible? I don't know now.
I see nothing.
Does everyone see nothing?
I think it's visible now.
Okay, so let's continue. What we have only done is we have created a new file called .env in the Foundry app folder, and then in the .env file we have placed these three variables that are here, which has private key, and we have gotten our private key from our MetaMask wallet. You go to your MetaMask wallet. You must not share your private key. I've even forgot account details. Then show private key and put in your password. You'll see your private key. Infura RPC URL, you can get it from infura.io. We did this in our previous tutorial. Then Etherscan API key. You go to Etherscan, and then you come here at this last, there is sign in. Once you sign in, you'll get your API key, and then replace the three dots with those things. So that's all that we have been doing, because now we want to deploy. So for us to deploy, we first load the environment variables with the command forge, not forge, source.env. So we have loaded our environment variables, and then we write the command to deploy. So let me put this in the Rise app. So for us to deploy, we are going to write these huge deployment scripts. So forge, should I clear or this is visible? I clear? I don't know now. Okay, so let me clear screen. I don't clear screen. Okay, so for us to let me do that. Now we are going to have forge create dash rpc dash url. Yes.
The screen is not visible. I don't know if it's happening to me alone, but I feel you're typing, but I don't see anything.
Okay, is it the internet or? Is it visible there? It's not visible?
It's not visible.
Yeah, I don't know how to help you because I'm also running out of power. I wouldn't want to. Is it visible? Okay. What is happening here? Okay, I think so we are going to deploy a smart contract. So forge create. We say it is Infura. RPC URL. Then of course private key. Private dash key. So these ones we put them in our .env file. Private key. And then for this we have to give the constructor args. So we said since constructor argument still gives us some issues, we are just going to at least 15 addresses. So I'm going to remove that and then give this 15. Yeah. So save, so that I can eliminate the constructor arguments as it causes errors. Dash dash etherscan etherscan dash API key dash key scan underscore API underscore key. So dash dash verify src. The reason why we are doing this is because this is in source whitelist.sol, and then the contract name is whitelist. So I have whitelist.sol, and then the contract name, which is whitelist. So let me take a screenshot. It's time to showcase what we are doing on X. So the reason I'm doing this is to give us that culture, whenever you're doing something. But I usually miss this, I don't know where. Okay. So as I share this, I can let us keep looking at this, or some of us who want to copy it, and I don't know if it runs. So let me only share this screen. I don't know how to share it. So let me see. Let me just share. I'm using Marco trees. I really don't know where my pictures go to. where do really my pictures go to? Even yesterday I failed to pictures. Today I need to get to know really where do my pictures go to. So let me take another screenshot. Okay, I think they go to documents. All right, so sorry for wasting your time, but sometimes you have to to be on something, because yesterday my picture also just disappeared. So today I wanted to be more deliberate about it, and yeah. So I'm going to tag everyone who is in the rise up, twin cake array. So this is also a session. You should learn by doing. We have very little retention on X. The only X and I'm seeing Maria Nakib.
Nachibuka.
Maria Nakib.
No, like Nachibuka.
Okay.
Yeah, that one.
Maria Nachibuka. Alright, so yeah, those are the ones in the okay, so let me put those ones, and yeah, done. Post. So let's press enter, and just as soon as I press the enter thing, the private key, so dash private, yeah, it's supposed to be private dash key. So I'll bring back the private key, a value required RPC URL, forge create RPC URL, but none was supplied. And this is not good. Forge create dash RPC dash URL. Infura RPC URL private dash key, Etherscan API key, dash verify. So I don't know why, for some reason, really Foundry has a lot of issues on deployment. Okay, correct reporting. What version of Foundry are you using? Forge. When running Forge scripts, we are missing. This is because our PC URL is an alias to fork URL. This message is constructed automatically by the CLI lib use. Unless are a big deal, this could probably be filled on. Clap though. So I don't know why I get this. Value is required. And none was applied. So if I don't get a solution for this, am I sharing my screen? Okay, all right. So if I don't get a solution for this, I'll use another method. But the good thing with this is that it really verifies your smart contract on the go. What could be the cause? So we first go through the, I think this first thing hide. So make sure support your RPC value maintained. Run the command source. Okay, forge test dash. Make sure support your RPC URL value is maintained, and if I run the command source and in the command, verify that the folder is exported by echo and run this command. So let me try that. Oh, I had not put Infura, I just left it at RPC, so it's supposed to be Infura. And let's go RPC URL. So I had not written the Infura, I had not written Infura RPC URL correctly. I had not written this correctly. I think that was the issue. So let me, after that, guys, I need to clear my terminal, or I can open up a new terminal for now. Let's leave those errors alone. What's happening? So okay, cd foundry up. So we are in foundry up and following on this error, the solution given here. Why exactly? So make sure this RPC value is maintained in your env. Run the command source .env. And then verify that the value is exported by echo. So infura RPC URL. So echo infura RPC URL. So yes, it is yeah. So let me go back and see if I can get my, I will not get my command, so let me rewrite it. So today is a very huge session, debugging and everything live, which is also a good experience. So it's normal for us to fall into issues. Forge create -- RPC. If you see me making an error, you can correct me immediately. Infura RPC URL -- private -key private _key. Can command B to extend this. Then Etherscan API. So -- Etherscan -API -key. Etherscan _API key. And then -- verify. So src whitelist .sol whitelist. So it has compiled successfully. So on this we are going to put -- broadcast to have it deploy. I think now let's deploy, and then I'll share this command in the group, in the pad. Yes, I think we are good, and now we are verifying the smart contract. So we have deployed successfully. And now a deployer, my address deploy to. So this is the address. I'll go to Sepolia scan. So if I paste my address and then search, so I'm a few sticks to, is it searching? It is still loading. So as it is loading, I can share this command in the Rise app. So that's the command. And then the deployed address. I don't know why my internet is really slow. So this is my smart contract, and when you look at the contract, there is a green tick around here. So if I click on it, it shows that my contract is verified, and the source code of my contract can be seen and everything, so that somebody can prove that it is true what my contract is doing. But even with this, you can really interact with your smart contract. For example, if I go to read, I think it's still loading. For those, you can also search the smart contract on your computer or your phone by visiting Sepolia scan. So on my end, contract is still loading because of, I think, the speed. Okay, hopefully it is done. So if I come to read, there you see there are the read functions. So maximum whitelisted address with the 15, and then the number of addresses whitelisted, there is 0, and whitelisted address, there is nothing. So for this whitelisted address, it returns a bool, whether if I put in a wallet, it shows whether the address is whitelisted. So you could have a front end that shows whether the visitor's wallet is whitelisted, probably when they visit and connect, or something like that. But for this sake, we are going to use this. If I go to write contract, and then I connect my address. You can also, by the way, try this out, because I've put the smart contract in the... So it shows that green and connected. So if I come here, I can write, so add address to whitelist, then write. So this will prompt my address to get added to the whitelist. So this whitelist will be for those who receive my NFTs during the airdrop. So if I come here and then I query see maximum addresses whitelisted 15. I think this should be refreshed. View transaction. So it shows that actually this address has been whitelisted. Let me get this smart contract, and then whitelist my second address from the other browser. So if I go to contract, and then under read contract, so you can connect or just read balance of get. I think this is not the same contract. So command copy, and then search. So I'm on Sepolia. I got contract, read. So number of whitelisted address, I see 1, which I whitelisted previously. So if I put in my whitelisted address, if I put in this address that I want to whitelist to check whether it is whitelisted, it has to return false. So bool, false, not whitelisted. So write to a contract, connect to the Web3. So even from Etherscan, without our front end, yeah, I'm connected. I think I had connected to it, then write. So confirm, and until 15 addresses are complete, so the whitelist will be full. So if I read and then it's the same, I query again. So this time it is true. Number of whitelisted address, I think here we should have a refresh, but that's the concept. So you can copy and then whitelist your address. Yeah. So we can now write not maybe, but we can write the NFT contract. So now let's start thinking about probably the NFT contract. Let's put forth the following requirements. There are a total of, we can say 20 NFTs that can ever exist. Users should be allowed to only mint one NFT per transaction. Whitelisted users should be able to mint the NFT for free. Other users need to pay. We are going to put maybe 0.01 ETH to mint the NFT. So those are the conditions we are going to take on. And let me share the conditions here. I think tomorrow we shall dive deep a bit in IPFS in detail so that we keep moving one step to another, step by step in the NFT arena and the entire ecosystem. So the rules. I'll put the rules in the rise up. That we are going to follow to create the NFT. So using the same let's go to install Open Zeppelin because we must utilize the ERC721. So this is the command to install Open Zeppelin. Okay, let me just write it because I think it is network that is showing it is here. Forge install Open Zeppelin contracts and so check the current Git repository status with Git status. Then you can track files with Git add and commit them. With the no commit. Okay. So contracts. By the way, you can also fall into such like errors. So learning to debug them on the go is very no dash commit comes very handy. All right, so opening the door is a good idea. So now we do the remappings to ensure that, so forge remappings, remappings.txt to register the imported smart contracts, and immediately the remappings.txt file is formed or is created. So we can now create a new smart contract in the SRC folder. I think we can call it, let's call it crypto devs. That's all. So let me share the code. For the NFTs. As I'm sharing the code, since the computer is loading, I can check on my X account. Okay, you miss a few minutes of the session, then boom. You're saying gibberish. Anyway, that's what we are learning today, and I'm hanging in there. It keeps surprisingly fascinating. The other computer of mine where I have to post the code is a bit slow. I don't know for what reason, but I've worked on increasing my bandwidth, so okay, so let me post start. And here end. All right, I think yeah, let me stop at that. And so let me copy this code. Code has not yet shown up here. So let me use a mechanism to get the code. So yeah, this piece of code will show up in the rise up, but for this, let me use my own Telegram. I think it is faster. Okay, so we can go through it. So for this, we are going to use 13. And of course, we have opened the Open Zeppelin. We are importing the whitelist.sol. We have it here already. And then is here C20 enumerable and ownable comes from these two imported smart contracts. So we have set the price of, I'm going to just set as 0.001 Ether. And then maximum number of the ENFTs in the collection is 20. We can put it 20 number. So whitelist, yeah, initialize the whitelist contract. And then we have, of course, number of tokens reserved for the whitelisted members, and reserved tokens claimed 0. So here we are going to initialize the whitelist in the constructor and get, because we want to get the reserved addresses. So that's the main instance of initializing this. And then mint okay, sorry for this silence. So we have the mint, total supply plus reserved tokens. Okay, so we must not exceed the total supply for free, and also the total supply at well. So we have 15 address, and each address means one of the tokens. So that means that maximum of the mint can be 20. So we only have 15, and then the other 5 people will have to pay 0.001 Ether. So that's the entire thing that is being explained here. And of course, we must be able to withdraw if somebody sends this Ether to mint their token. their NFT. So this function is very, very required. Function withdraw, a public only owner, and then you should have a payable so this should have a payable function. So from function mint, it should be payable. So this shows that in this function, it accepts Ether. Then you should have the withdraw function, which should give you the capacity to withdraw the funds that you want to withdraw. Most of the things are self-explanatory, and I think the code has reflected in the pad, in the rise up. I don't know why it is not reflecting in the rise up. For some reason, let me just put it. It might conflict, so let me delete it from here. And then so each one of us shall go through it when we have time. So let me pull off my terminal. I think now I'm authorized to use the first one, so I can clear now for this one. So to deploy, I will still write how many commands. Why is this really giving me headache? So this should be the forge, create, so when you look into this smart contract, I'm going to have to create some. So here whitelisted is equal to whitelisted, the whitelists from, so the addresses that come from this smart contract. So what this means that this smart contract will read through our smart contract. And then read, of course reading does not require gas, so read the whitelisted addresses. So there are two, and then it picks them. So what we are going to do to avoid using constructor args, probably we can try today. It might be something that we could solve. Forge, create, -- rpc -url, infura, /private, my battery is really getting low. So instead of verify, I'm going to have the constructor args. Constructor args. So the smart contract of the whitelist address, so that it knows and then we have dash verify. So the function, the contract crypto devs. So this is crypto devs.sol, and then the contract crypto devs. Capital D. A value required for RPC URL. Infura RPC URL. Forge create. So they told us for this what you have to do. Oh, I've understood. I think this this command line still remembers that there is no value, so I'm going to delete it and then use this one that hopefully here people can see. So forge it has scan, enter. Forge create RPC private key constructor args. The following required arguments were not provided. So I'm going to just share this screen only. So best run the command source .env source .env and then verify the value by echo. So I don't know why. Is maintained in .env file. It is maintained. Run the command source, verify, and run this command again. So as if these values are not being read. Is it that I'm making an let me create a new tab. So I think now it has worked. And let me see. So forge. What? So I think if it doesn't work, it will be an issue of the constructor args. What I'm going to do is to deploy this using Remix. So this is 13 and this is 13, 0.8.13. Control save. Okay. Whitelist.so. So new whitelist.so. Copy and then paste. So yes, everything is okay. Then we can deploy. Injected provider should be on Sepolia 115. Yes, that is it. Whitelist address. So it was this one. It's also in the rise up. Oh, here, no. I'm on this one. So 0.8.20. So these are the reasons I really want to use Foundry. Yes. Because this is now going to really disturb me. Warning. Okay, not provided. That's totally fine, but I can put it there. So SPDX license probably could look somewhere here and copy it to crypto devs. But this would be very, very good if you are deploying in Foundry. So we need to figure out, yes, it has been successfully compiled. Injected provider. So here the address of the whitelist contract. And I might not even search for it. It is here. So this will show whether an address, a wallet address is whitelisted or not. And I can put it here and deploy. So if you don't put that address, you cannot deploy. Yeah. So confirm. All right, now our address is here. We can do our best to verify it. Crypto devs. So flatten. Crypto devs flattened. Before that, let's go and copy it. Search it here. And then contract doesn't have that tick. Verify and publish. Let's try to verify and publish. Select compiler, single file, 20 I think it was. Yes, it is 20. Select open source license, MIT, continue. I'm running out of battery. So enter the Solidity smart contract. To devs flattened, control copy, and then a paste. So verify constructor argument. I add. So we can leave it if it is failing. And then so the way we have to test this is we have to really have it like verified, because we are going to write to those smart contracts or to those functions, and we can't write to them when they are verified from Etherscan. We can only write to them in the front end using the API. So I'm going to contract address I'm going to try verifying the second time. Copy and Control-V, compiler type, Solidity, compiler version 20, open source license, identifier MIT. Enter the Solidity contract. This is the flattened version. The constructor arguments. So the constructor arguments was the address of the smart contract. Let me check if I can see it. I think it is here. Control copy. Verify and publish. So invalid construct arguments provided. So I don't know why it is failing. let me look at crypto devs. So this is the address of the whitelist contract. Okay, so a second deployment has been constructed for contracts that were created with construct argument parameters. So since it has failed, we can leave it. But you will find that if you access the methods of this contract, you can be able actually to mint these NFTs to these wallets until the whitelisted addresses are done, and anyone who would want to mint will have to pay the 0.001 token. Now the essence of this was to introduce us to something called macro trees, and the reason is because this is somehow inefficient in a way that you have to have the whitelisted addresses maybe stored somewhere or on chain, and storing those addresses can become very costly as they increase in number. Or as they increase in number, when there is data increase on chain, it becomes very costly. Just imagine you're airdropping to maybe 100, 1,000 wallets. That's too huge data. So that goes for the introduction to Marco trees. And due to my battery, I'm going to stop there. But when we come, we shall really dive deep into those Marco trees and Marco proofs, and also see how the blocks keep data in a very light manner, so that the blockchain, keeps being fast. Yes. So Marco proofs are about just knowing parts of the information, and you don't need to iterate through the entire array or list, but knowing part of the tree can prove whether a transaction was part or not part of that block. All right. So any questions are welcome. On a serious note, electricity has failed us. It has failed to come back, and my battery is running low. If there are no questions, any questions?